Alright, so 4.2 is getting away from the naming part of what you were doing in 4.1 and actually going into what they're doing to be combining in the first place. So we looked at, we didn't really ask ourselves why we're naming these compounds the way they are, like meaning why is H bonded to O and how is sodium bonded to chlorine and all these kinds of things. Now we're going to go really into the types of bonds. There are 4 bonds. We're going to talk about the key words, characteristics, and examples of each one. And the 4 types are ionic, polar covalent, covalent, and metallic. So if I give you a substance and you can make some tests on them, you should be able to tell me which one of these they are. Okay? So let's go through some key words for ionic first. Ionic has the word ion. There are 2 ions. There are ions that gain electrons called anions, and there are ions that do not gain electrons. They lose electrons called cations. So it has the word ion in it, so you know that it's involved of losing and gaining electrons. Okay? And we're going to use the word transfer. So we transfer electrons. Okay? Transferring electrons makes it have a negative and a positive side. So that's negative and positive side to it. So if I had an A and a B, basically what happens is one wants an electron, or one has an electron, or 2, it could be a metal, right? 2 or 3 electrons. And this side would love to have there's an empty spot there. So I'm just going to put 8 dots around here, or 7, meaning there's an empty spot right there. That electron's going to go to the B, making A very positive. And then B, since it has an electron, is very negative, because A now has 1 more proton than it does electrons, and B has 1 more electron than it does protons. So that transfer makes a positive and negative side, and that allows that bond to be very, very strong. This is an ionic bond. So, in characteristics-wise, we're talking about physical properties, okay? So it's going to have a high melting point. It's going to have a very high melting point. It's also going to conduct electricity. So I'm going to word the conduct electricity. All right. And it also, if you throw an ionic bond, like a substance that has an ionic bond in water, it will dissolve. So it is soluble. Soluble in water. I'll just put H2O. Okay? So it's a high melting point, conducts electricity, and it's soluble in water. Now, about conducting electricity. It only conducts electricity if it's in solution. So, for example, for those hunters out there that attract deer with a salt block, that salt is an ionic bond, but if electricity will not pass through it because those ions need to be separated in water. And then it will conduct electricity. So, conduct electricity in water. All right? So conduct electricity in water, soluble in water, and has a high melting point. Okay, so it's very strong. High melting point, as we know from the last unit, means it's very strong. Okay, so examples of this is any metal and a non-metal. So metal plus a non-metal. I'll just put Nm for non-metal. So we could say NaCl. We could also say I don't know, CaCl2, and hopefully you know why there's a 2 there. Calcium needs 2 electrons to give away. Cl, each one will take 1, so therefore you have a 1:2 ratio. Anyways, these are all examples. Just look for an element on the left side, a metal, and bond it with something on the right, and you got yourself an ionic bond. Polar covalent bonds are a little different. We're going to be sharing electrons, but we're going to share them unevenly. So we're sharing electrons unevenly. That means that electrons, let's just do this again. So we have an A and a B. We're just going to say that these electrons, say B needs 2 electrons. All right, so there's 2 empty spots here. And A also has 2 empty spots. Well, what happens is their electrons are going to pretend that they are in both empty spots. So they're going to go over to the empty spots of the other element, and the other electrons are going there. So they're all sharing them. The only difference is electrons are being pulled one way more than the other. So let's just say B likes electrons more than A, that's going to make B a little bit negative and A a little bit positive. Even though, so it's not a transfer of electrons, it's just the electrons are being pushed to one side more than the other. That makes the B more negative if B would pull electrons more. So more electronegative, so it's uneven. So that's why it's polar. Okay? Polar means it has the word pole in it, has a positive and minus side in it. Okay? So characteristics, it's going to have, it's not as strong of a bond, so it has a low melting point. Okay? It is polar, so therefore water is an example of that. So it is soluble in water. Soluble in water. Okay? And it does not, because it doesn't have any ions, it has no metal. Metal conducts electricity. Ionic bonds always have a metal, right? Polar, these are all non-metals bonding, okay? So I could even put non-metals only here, non-metals. So non-metals only for polar covalent. Covalent means sharing, only non-metals do this. So therefore, no conduction. It does not conduct electricity in anything, or as a solid or liquid or whatever, okay? So examples, like we were saying, is, you know, H2O is definitely an example, HI. These are where electrons are being pulled more than, in one way more than the other. And it makes one side more negative than the other, but it's positive. Covalent, on the other hand, covalent, I should say covalent, polar covalent, or non-polar covalent. So non-polar covalent. I guess I should keep up with the colors, sorry about that. So I'm going to use green, I should have done purple there, but anyways, non-polar covalent means you're going to share in electrons. So you're sharing electrons evenly. So again, over here, an example. So that just means that those electrons that go one way versus the other are being shared evenly, so there is no positive, there is no minus side, because they're equally spread out. So that means it is a very weak bond, lowest melting point. It is not going to be not soluble, non-polar, like oil. Definitely not soluble in water, so not soluble in water. And no conduction because it has no metal. Remember, this is non-metal again, so no conduction. All right? So examples of this would be anything that that would be the electrons evenly distributed. So CH4 would be an example. Any diatomic element, H2, N2, or H2 and O2, all those are examples. Okay? So next we're talking about metallic, and that's the last one. Metallic is, this key word here is C of electrons. C of electrons, okay? That means electrons, I'm just abbreviating, I just wrote the whole thing there. So that would be where I'm going to actually use any metal, okay, let's just call it A. They basically are having a block party of electrons. So they just throw their electrons out for everyone to share. So it's like a potluck. And these electrons are kind of all around these atoms, these metallic atoms, and they're able to move, the atoms are able to move within those electrons, sea of electrons. And that makes it malleable. It makes metals be able to bend. That's one of its characteristics. Also, it makes all of these a positive charge. So these metals have a charge because they threw their electrons all out. And these electrons are like the glue that will hold them together. So we have a very high melting point. It's definitely not soluble. Think about a metal. Metals do not dissolve in water, thank goodness. And it does conduct electricity as a solid. If it was a liquid, it would not. So as a solid, it conducts electricity. So examples, just grab any metal, copper, iron, we can do chromium. All those are examples, okay? And that makes metallic bonds. They're just one copper atom, a bunch of copper atoms throwing their electrons out and bonding to each other. Okay? So anyways, these are the types of bonds that you're going to see on the test. So make sure that you know that, and also how you can characterize them, okay? So try some examples out, try the practice test, has some really good questions at the end, and that might help you, okay? Good luck.